This unit today is about production of batteries, and in particular on the production of lead-acid batteries. Obviously, there are many other battery systems around, but certainly a number of these will have similar production methods. Once it comes to redox flow systems, for instance, the production is merely on material synthesis of usually simple compounds, and that is not part of this MOOC. Therefore, we will focus here on lead-acid batteries. Once we are opening a lead-acid battery, we have typically 6 cells, which are constructed with numerous laminates containing the positive electrode, the negative electrode, and a separator mat, which is soaked in sulfuric acid and separates the electrodes, preventing shorts in the cell. These various laminates thus need to be produced, and we follow this along the following production steps: lead powder manufacturing, grid formation, plate manufacturing, assembling the battery, forming the battery, where charging and discharging of the battery is done before it becomes available for the customer to make sure it works and is safe. The assemblage and formation of the lead-acid battery are best viewed by a video on internet, which you can find at. The active component of a lead-acid battery obviously is lead. Standard lead bars are crumbled into slices or powder, and as such oxidized under controlled atmosphere, where in the end a white and yellowish powder of lead oxide is being formed. This powder is referred to as lead powder. The grid serves as both construction current collector and active material carrier. It is fabricated by melting lead with the proper additives such as antimony, calcium, or even silver, depending on the use of the lead-acid battery. The melt then is poured into a mold to form the grid after cooling. Lead powder is mixed with diluted sulfuric acid, and important additives are homogeneously smeared on the grid surface. This then will be dried and to finally solidify the layer to create the unformed plate. To manufacture the actual battery, the unformed plates and the separator mats are placed in the plastic case. Concentrated sulfuric acid with a concentration of 6 molars is being added, which will act as the electrolyte. The whole assembly is then sealed depending on their application. Finally, the battery is formed to create the active components at both electrodes. As mentioned earlier, these 2 steps can best be watched on the video posted on Bing. It is however mentioned that the formation steps also depend strongly on the way the battery is being used, meaning its application in a start, lightning, ignition battery, or a battery for static applications such as in-home batteries. This is however quite standard for battery producers, so also for lithium-ion batteries.